Good day everyone, and I welcome you again to TV Patrol Anatomy, special sponsored by Show Herbal Capsule. 12 tip nila. Today I will be reporting about our headlocks, the urinary system, the body's way of excreting our wastes, and its importance. Today, I'll be presenting you an animated video clip about the urinary system and how it works.
The renal system consists of the kidneys, the connecting arteries and veins, and the urinary tract. The kidneys are paired, bean-shaped organs lying outside the peritoneal cavity in the back of the upper abdomen, one on each side of the vertebral column. The kidneys function as the body's main excretory organs, eliminating the body's metabolic waste products by filtering the blood. Substances that are unneeded or are present in excess are filtered out of the blood and form into urine, moving via the ureter into the bladder before being expelled through the urethra. The kidneys also selectively reabsorb those substances that are needed to maintain the normal composition of the blood. By adjusting blood composition, the kidneys are able to maintain blood volume and pressure, ensure the proper balance of sodium, chloride, potassium, calcium, hydrogen, phosphate, and pH, and eliminate products of metabolism such as urea, uric acid, and creatinine. The medial border of the kidney is indented by a deep fissure called the hilus, where the blood vessels, nerves, and ureters connect to the kidney. The kidney is composed of up to 18 lobes. Each lobe is composed of nephrons. Nephrons are the functional units of the kidney, and each kidney contains more than 1 million nephrons. Each nephron consists of a glomerulus and a system of tubules. The glomerulus is a unique, high-pressure mass of capillaries that filters the blood. The glomerulus is encased in a thin, double-walled capsule called Bowman's capsule. The space inside the capsule and surrounding the glomerulus is called Bowman's space. Plasma-like fluid is filtered from the capillary blood into Bowman's space through the glomerular filtration membrane. The glomerular filtration membrane consists of 3 layers of capillary wall: the endothelium, the basement membrane, and the epithelium. This membrane allows some particles from the blood to pass through, but not all. The fluid that is filtered from the capillary blood into the Bowman's space is called filtrate and forms the primary urine. The filtrate then diffuses across Bowman's space and into the tubule system of the nephron. In the tubules, some substances are added to the filtrate as part of the urine formation, and some substances are reabsorbed out of the filtrate and back into the blood. The nephron tubule is divided into 4 segments. The filtrate passes through each of these segments before reaching the ureter. A highly coiled segment called the proximal convoluted tubule, which drains Bowman's capsule and where almost complete absorption of nutritionally important substances takes place. A thin looped structure called the loop of Henle, which reabsorbs water and ions from the urine and plays a role in controlling the concentration of urine. A distal coiled portion called the distal convoluted tubule, which regulates potassium, sodium, and pH, and where further dilution of the urine takes place. And the collecting tubule, which joins with several tubules to collect the filtrate and where final sodium regulation takes place. Each kidney is supplied with blood by a single renal artery that arises on its respective side of the aorta before dividing into 5 segmental arteries that enter the hilus. Within the kidney, each segmental artery branches into several lobular arteries. The lobular arteries further subdivide to form interlobular arteries, which branch off into afferent arterioles. Blood flows into the glomeruli through the afferent arterioles. Blood flows out of the glomerulus through the efferent arteriole. The afferent and efferent arterioles regulate glomerular capillary pressure by selectively dilating or constricting. The kidney's venous blood, now filtered, flows from the glomerulus via the efferent arterioles into the peritubular capillary network, a low-pressure, reabsorptive system surrounding all portions of the tubules. This arrangement permits rapid movement of solutes and water between the fluid in the tubular lumen and the blood in the capillaries. The peritubular capillaries rejoin to form the venous channels by which blood leaves the kidneys and empties into the inferior vena cava. Urine formation involves the filtration of the blood by the glomerulus to form an ultrafiltrate of urine, the tubular reabsorption of electrolytes and nutrients needed to maintain the constancy of the internal environment, and the secretion of waste materials. Filtration occurs as blood flows into the glomerulus from its afferent arteriole, and plasma moves through the glomerular capillaries into Bowman's space. From Bowman's space, the glomerular filtrate moves into the tubular segments of the nephron. Here, through tubular reabsorption, electrolytes and nutrients move from the filtrate back into the bloodstream. Here also, through tubular secretion, substances move from the peritubular capillaries into the urine filtrate. The filtrate concentrates in the collecting tubules, then finds its way to the renal pelvis, where it is directed to the ureter, the bladder, and the urethra for elimination. The kidneys perform an excretory function by filtering the blood and then selectively reabsorbing those materials that are needed to maintain a stable internal environment. The nephron is the functional unit of the kidney and is composed of a glomerulus, which filters the blood, and a tubular component, where necessary substances are reabsorbed into the bloodstream and unneeded materials are secreted into the tubular filtrate for elimination in urine.
Thank you very much for that wonderful video, and now please stay tuned because we'll be having a quick break, and please watch the commercials.
Ako si Jansel Talavera, tumuluyo sa mulo. Sa una, naaguma ko kasakit sa ako ng kidney, dire. Tuwa na sila kabilog. Tapos nga ako nangihi ito, tulo-tulo. Inang gamay-gamay lang, tulo-tulo rin gamay-gamay lang, tapos ko mangihi, masakit. Pusang nag-inom ako sa Joy Herbal Capsule, dito ko ginabalan ng iyang pagka-epektibo. Nadula ang sakit sa akong kidney, ang akong nahi, tayo yun. Sa subong ka pangihi ko gani, subong sa kanami, sa Joy Herbal Capsule muna. So, madamo, salamat sa Joy Herbal Capsule.
Ano mahambal mo sa Choy Herbal Capsule? Yun yung affordable bala sa tanan?
Oo, mabarato lang kay 12.50 lang. Kaya mabakal mo ng Choy Herbal Capsule. Ganami ganyan inyo pangihi. Sa subong ka pangihi ko gani, okay kanami sa iya. Kita nyo, muna, subong, narekomenda ko sa mga pumuluyo na nag-augbo kasi ano nga sakit, labi na sa pag-ihi, na mag-inom ka mo sa Choy Herbal Capsule.
Choy Herbal Capsule, God's pathway to herbs that heal. Thank you for staying with us. That commercial was brought to you by Choy Herbal Capsule, 12.50 lang. God's pathway to herbs that heal. And next, another animated video clip will be brought to you by Mr. Jansel Talavera about your information. Jansel, pass it up.
Urine is one form of the body's waste. It is formed in the kidney. And urine is excreted in the body. Let's watch this animated video, the formation of urine.
One of the primary functions of the kidney is better understood at the level of the nephron. In forming urine, the nephron functions to remove metabolic wastes from blood while regulating the volume and composition of body fluids. Urine formation begins in the renal corpuscle, where blood passing through the glomerulus is filtered. Filtrates include water, ions, and other solutes, which are filtered out of the blood and into the capsular space to begin urine formation. Urine passes into the proximal convoluted tubule, then into the nephron loop. The nephron concentrates urine by the process of the countercurrent multiplication system. The countercurrent multiplication system is basically the means by which water and sodium are extracted from the filtrate as it passes through the tubules toward the collecting ducts. This system is called countercurrent because of the dynamics set up by the hairpin turn of the loop of Henle. The direction of flow in the descending limb of the loop is opposite from the direction of flow in the ascending limb. By flowing in opposite directions in such close proximity, a unique interaction occurs. The loop of Henle dips from the cortex of the kidney into the medulla, and is surrounded by the medullary interstitial fluid. The countercurrent multiplication system is responsible for not only elevating the concentration of urine in the loop, but more importantly, it elevates the concentration of the interstitial fluid as well. To explain the countercurrent multiplication system, we must first imagine the loop filled with a stationary column of glomerular fluid, which includes water, salt, and urea. At first, the concentration of the glomerular fluid and the surrounding interstitial fluid will be equal at an osmolarity of 300 milliosmoles. Within the walls of the thick segment of the ascending limb, special pumps extract salt, sodium chloride, from the fluid and transport it to the interstitium. The two areas no longer have an equal osmotic pressure, and a gradient has been established. Within the thick segment, the concentration is at 200 milliosmoles, whereas in the medullary tissue, the concentration is at 400 milliosmoles. Over time, a net diffusion of salt into the descending limb and a net diffusion of water out of the descending limb results in a balance in osmolarity between the descending limb and the surrounding interstitium. Because the thick segment is still actively pumping out salt, the osmolarity of the ascending limb is still 200 milliosmoles, and the interstitium and descending limb are balanced at 400. Salt accumulates in the medulla while water is drawn out of the fluid in the descending limb. Water is removed by the vasa recta, which are capillaries that surround the loops. In real life, operation of this gradient occurs while the fluid is flowing. Fluid flowing in from the proximal tubule and out to the distal tubule, along with the constant pumping of salt into the medulla, contributes to the multiplication of this gradient. As fluid follows the path of the loop, an increasing amount of water is extracted as it reaches the bottom, and an increasing amount of salt is pumped out as the fluid reaches the top. The more salt pumped out, the higher the concentration in the medulla. The higher the concentration in the medulla, the more water is extracted. Eventually, the levels of osmotic pressure are equal horizontally, with the highest value being at the tip of the loop. This level is at 1,400 milliosmoles per liter, which is also the value of the maximal osmolarity of excreted urine. As you can see, fluid becomes more concentrated as it rounds the loop, but it immediately becomes rediluted as it reaches the top. Final concentration of the fluid occurs in the collecting ducts, as it must travel back through the concentrated interstitium of the medulla on its way to the calyces. Urine is concentrated even further in the collecting ducts. The collecting duct must transport urine back through the concentration gradient formed by the nephron loop. The walls of the collecting duct are permeable to water, but not to salt. Therefore, an increasing amount of water is drawn out by osmosis as the fluid travels through the gradient. The gradient provides the force for the concentration of urine, but the rate is determined by the amount of antidiuretic hormone, ADH, in the blood. An increase in ADH in the blood causes the collecting ducts to become more permeable to water. Less urine is secreted and it is more concentrated. A decrease in ADH results in a decrease in water removed, thus a larger volume of more dilute urine is excreted.
Thank you very much, Talavera, for the video about your information. And now let's head on to our clinical correlates. Bladder infection and kidney stones are an utmost problem in this society right now because the statistics show that it is one of the most prevalent disease or urinary tract diseases worldwide. So I'm proud to tell you that Miss Shirley Escarlan would be the one presenting the video clips about these certain urinary diseases. Please watch. Good afternoon, viewers. I am here now with Miss Shirley Escarlan who will be explaining to you bladder infection. Shiro, what is bladder infection?
Bladder infection is also called as cystitis. It's a bacterial infection in the bladder that some people call a bladder infection as a urinary tract infection, which refers to a bacterial infection anywhere in the urinary tract, such as bladder, kidney, ureters, or urethra.
And what are the causes, or what is the cause of bladder infection?
Bladder infections are caused by germs or bacteria that enter through the urethra and travel into the bladder.
its symptoms? Does it include pain in the lower abdominal region? Because maybe some of our viewers right now are experiencing bladder infection without them knowing it. So can you please tell us what the symptoms are?
So if you have a bladder infection, you could feel or experience cloudy or bloody urine, foul smell urine, low fever, pain or burning when urinating, and cramping or pressure in the lower abdomen or lower back.
Oh, okay. So thank you very much for that, sharing this, Caroline. And for a more detailed view of bladder infection, we will be showing you a video. So stay tuned.
A lower urinary tract infection is an infection of the urethra, the bladder, or both. The urethra is a tube that carries urine from the bladder outside the body. The bladder and the urethra are part of the urinary tract system. That is why a bladder infection is also called a lower urinary tract infection. If you have a bladder infection, you often feel a burning sensation while urinating and a pressure or painful sensation in the lower abdomen. You often feel that you have to urinate, but not much urine comes out during urination. The urine may have an unpleasant smell and may sometimes have blood in it. The most common cause of a bladder infection is a bacteria that infects the bladder mostly through the urethra. There are different factors that increase the chances of a bladder infection, which goes along with increased risk of bacterial infection. Not enough fluid intake, sexual intercourse, bad hygiene, bladder or kidney stones, pregnancy, menopause, diabetes mellitus, if you have a catheter, birth defects of urinary tract or kidneys, chemicals. Women have bladder infections more often than men because women have a shorter urethra, causing easy entry of bacteria from outside into the bladder. Even though it is often thought, it's not likely that a cold or draft can cause a bladder infection. A bladder infection is an annoying and painful complaint that in general can be treated well. The GP may prescribe antibiotics to speed up the recovery of a bladder infection and prevent complications like an infection of the ureter, kidney, pelvis, etc. To prevent bladder infections, it is important to drink 2 liters of water daily. Frequent urination washes out the bacteria. Don't resist the urge to urinate, but go to the bathroom as soon as you feel it. Always make sure to completely empty the bladder when urinating. For some women, a bladder infection recurs less frequently if they urinate after having sex.
Thank you very much for that, Ms. Shirley Escalante, for presenting us a wonderful video clip about bladder infection. And that concludes my report for this day, and I hope you enjoyed and you've learned a lot. So once again, this is Romeo Japera Jr. from TV Patrol, Anak.